Dear students, in this video, uh, we'll deal with the topic of isomerism. Isomerism. What's isomerism? Isomerism may be defined as a phenomena in which molecules have same molecular formula, but their structures or their three-dimensional arrangement of atoms or groups is different. This is known as isomerism. Iso means same, mers means parts. So same parts, molecules which have same parts, they are known as isomers, and the phenomena is known as isomerism. You know it very well. Actually, we have to discuss a stereoisomerism, but first of all, I would like to divide this isomerism into two parts. One is known as structural isomerism. One is known as structural isomerism. Structural isomerism, and another is known as stereoisomerism. Structural isomerism. What are structural isomers? We define them as those molecules, those compounds or molecules which have same molecular formula, which has same molecular formula but different different connectivity, different connectivity of bonds. Means their bonding is different. So molecules, those compounds which have same molecular formula but different connectivity, means different kind of bonding they have. Such isomers are known as structural isomers. They are called as structural isomers. Structural isomers, example, if we take, there are so many examples. We'll take the example of this molecule CH3 CH2OH and CH3OCH3. These two molecules. You can see the molecular formula of these compounds is same. 2 carbons, 6 hydrogens and 1 oxygen. So molecular formula is same. But their structures or bonding is different. They have different bonding. So such isomers are known as structural isomers. So this ethanol is structural isomer of dimethyl ether. So this is a structural isomer of dimethyl ether. They are also known as constitutional isomers. Means their constitution is different. They are differently constituted. Other examples I will tell you. You can see ethanol, as I already mentioned, and dimethyl ether. They are constitutional isomers. They are structural isomers. Here you can see 1-chlorobutane and 2-chlorobutane. They are also structural isomers. Why? Because their molecular formula is same. You can see, but they have different bonding. Here you can see this chlorine atom here. It is attached to carbon number 2. This is carbon number 1 and this is carbon number 2. So chlorine is attached to carbon number 2. So it's known as 2-chlorobutane, it's called. In this molecule, this chlorine is attached to carbon number 1. So the bonding is different. You can see the bonding in these two compounds is different. In one, chlorine is attached to carbon number 2. In second, chlorine is attached to carbon number 1. So they are constitutional isomers to each other. Another example is pentane and isopentane. Here pentane, you can see they have different structures. Molecular formula is same. Here you can see it's an unbranched chain. It's a branched chain. You have a branch here, CH3. So the structure is different. Acetone and propionaldehyde. You can see their molecular formula is same, but they have different structures. Here you have a ketone functionality and here you have an aldehyde functionality. So these are known as constitutional isomers, or they are called as structural isomers. इनको हम structural isomers भी बोलते हैं. Regarding these constitutional isomers or structural isomers, I would like to add that structural isomers have different IUPAC names. इनके IUPAC नाम जो होते हैं वो different होते हैं. Means they are different compounds and they can have same or different functional groups.